trying to stay on track here, but I have like very little margin for error, so if I fumble, I go a little over, so that's why I wanted to start a little early. And then I wanted to say something at the very end of the second talk. But anyway, getting going. My name is Eric Wing. I'm very honored to speak here. 11 years ago, I had the privilege to attend the very first Lua Workshop in San Jose, hosted at Adobe. And I was pretty green, and I learned some great things at that workshop, which I carried with me throughout my career. And I dreamed of the day when the Lua Workshop might return, and I might be able to share things that would be of interest to other people. So today I had the privilege to give 2 talks. Ironically, neither of the talks are directly about what I'm working on right now, but projects from my past. I have great respect for this workshop, so I want to present some things that might be different from might be different than what's been done before, and interesting, and not just something you've seen in similar form before. Just my luck, there's a second Obj-C Lua Bridge talk this week. So for this first talk, I will speak about LuaCocoa. My goal is not to try to convince you to use it, but to share the experience and details of making it work. I hope there may be some common insights you may draw from it, perhaps for those of you who may attempt to bind to other languages and environments that share similar needs. My career has kind of a non-consistent background, and I've worn many hats. In this talk, I put on my native Cocoa cap, though sometimes other caps get into my thinking. And LuaCocoa is a project that spans many years and has been connected to many professional needs at the time. I want to pause here and say that LuaCocoa is also a very personal project for me. At the time I did the bulk of the design and implementation, my mother was dying from a long fight with GIST cancer. Desperate surgeries, experimental medications, emergency room trips due to complications. There was a lot of sitting and waiting and long nights. LuaCocoa was kind of an escape mechanism for me to avoid thinking about the situation. So LuaCocoa is connected to me in a very complex and personal way. I also want to say that the 9th annual GIST Cancer Research Walk for Here is happening next weekend in San Jose. My mother actually helped create the walk. If any of you are still in the area, please come, or visit the website. Donations are greatly appreciated because GIST is a rare cancer and doesn't get as much attention or funding as others. 100% of the proceeds go to research. So I have a lot of slides, so I'm going to be skipping a lot of things here. But to get everybody on the same page, Obj-C is a small, pure superset of C that adds object-oriented features to C. It takes heavy influences from Smalltalk, so messaging is another core concept of Obj-C. It likes late binding and dynamic dispatch. It is an unusual blend of a statically compiled typed language plus the dynamic features normally thought of in scripting languages. Cocoa is effectively the huge standard library for Obj-C. Foundation is non-GUI, AppKit is for the GUI. UIKit replaces AppKit on iOS. There are lots of other libraries in addition to Cocoa, some C, some Obj-C. So sometimes Cocoa is used to casually refer to all of these as a platform. Cocoa was designed for GUI development. It exploits a lot of crazy dynamic runtime features of Obj-C under the hood to make some really cool features of Cocoa possible. I wish I had time to discuss these in more detail, but I will mention swizzling because I use it in LuaCocoa. So ISO swizzling allows you to change the implementation methods at runtime. You can swap them, chain them, replace them, and do all sorts of crazy things. LuaCocoa's story really starts here with the Lua Obj-C bridge. It was a simple bridge that used only the Obj-C runtime. It did not use additional things like LuaFFI, which I'll get to later. But there were a lot of limitations. You couldn't subclass in Lua. You couldn't handle non-object types. This is a problem when you say add a struct as a parameter to a method. There was no automatic memory management. It did not use meta methods. But even with all the limitations, you still could get a lot of mileage with it, and it was still very useful. At the top is what a method call looks like in Obj-C. Below it is what it looks like in Lua Obj-C bridge. Most other language bridges look like something like this too. Lua core was a traditional manual static binding for common structs and C functions you would use in Cocoa programming. Used in conjunction with Lua Obj-C bridge, you could access a lot more of the system from just Lua. I took both of these and started enhancing them. This became the proving ground precursor to LuaCocoa. Everything changed in WWDC 2006. For most people, Obj-C 2.0 is a defining event, but for this talk, BridgeSupport is the key item. BridgeSupport makes it possible to fill in all of the shortcomings that the Lua Obj-C bridge had. Apple used it to finish giving PyObjective-C and RubyCocoa complete API coverage and officially included them on Mac. Obj-C 2.0 makes breaking changes. Some context. Apple was transitioning to first Intel and then 64-bit.
This was a rare opportunity to create a new API, so now is the time to break things. Unfortunately, functions Lua Object-C Bridge depended on were deprecated and not available on 64-bit. Thus, Lua Object-C Bridge would have to be completely rewritten. Also, Object-C 2.0 introduces optional garbage collection, which will have an impact on things. BridgeSupport basically provides XML metadata for things which Object-C introspection cannot discover, such as C structs, C functions, enums, pound defines, and global variable names. It can also tell you the intent of an API. For example, in Object-C, bool is defined as a signed car, but it really means Boolean. So in Lua, we can use a Boolean type instead of a number. And it will tell you about out parameters. So in Lua, we can take advantage of multiple return values. BridgeSupport also provides an extra dynamic library containing missing symbols for inline functions. Finally, the tool GenBridge metadata can be used to create BridgeSupport data for any library, so you're not just limited to Apple frameworks. Scripting Bridge is another technology that allows programs to communicate with each others through the AppleScript dictionary. This is an example of using LuaCocoa to play a song in iTunes and print out the track information. I've also written about scripting in Xcode for test automation. LuaCocoa takes from the Lua philosophy of mechanisms, not policy. I want you to use LuaCocoa as you see fit, and that also means supporting both sides of the bridge. While most bridges want you to write everything in the language, LuaCocoa takes the stance that you could, but that may not be the best use of your efforts. There are a lot of powerful tools in the platform to help you. Use the best tools available to you. In the places where Lua has a clear advantage at scripting, then LuaCocoa is there to help. Before starting LuaCocoa, I made sure to do my homework and research all the prior Lua bridges and talk to all these people. I also looked at most of the other language bridges and got help from some people. LuaCocoa is probably the most researched bridge ever. So these are some example use cases for LuaCocoa. This first one is based on a real project where we had a great designer on the team who wasn't a programmer, but he could handle some scripting. Core animation was the thing at the time. It's kind of like a video game sprite engine, but for native GUI stuff. But it's all programmatic, unlike other things Apple provides, so scripting is a win. The main app is a traditional Cocoa app with Object-C and interface builder, but I sectioned off a place for the core animation scripting, and I added all the live coding stuff. I don't want to spend a lot of time on this since most live coding demos are pretty much the same, but so I can open the script, and the buttons down here are programmed, mapped to call functions in that script. I also have a function that triggers immediately when you save. So I'll modify the script right now, save, and transforms. And then the scripter has full access to the system APIs, so maybe they want a movie. So they can bypass me and start playing video and do all these crazy things with the system. So that example comes with LuaCocoa. Another simple example is this silly Swedish chef translator. Again, it's a pretty conventional Cocoa app, but for the translation, I use LPEG because it's much better than anything I can get in Cocoa. LuaCocoa started with Lua 5.0, but eventually migrated to 5.1. Two patches to Lua are needed. The first is LNUM. The main integer type in Cocoa is 64-bit on 64-bit systems. It cannot be stored in double without potential loss. LNUM preserves the number type behind the scenes, so we get an integer through the bridge intact. Lua pcall doesn't know anything about Object-C exceptions, so this other patch fixes that. Lua has a macro for C++ exceptions, but it doesn't perfectly fit. I want to point out that this patch is useful for all cases of Lua on Mac and iOS environments, not just LuaCocoa. Basically, if there's an underlying call that happens to go into a system framework that happens to be using Objective-C, potentially it could throw an exception, and if you're in Lua, you're hosed. So my wish is either we get this patch incorporated into Lua directly, or Lua could be refactored slightly to make integrating this a little easier in the future. libffi is a library that makes it possible to call functions between different languages. Lua Object-C Bridge only used the Object-C runtime, so there were many limitations in strange cases. libffi is much more powerful and can be more efficient. All the other bridges use libffi, so LuaCocoa follows suit. Thanks to BridgeSupport and libffi, we can now bind any C function at runtime automatically. Inline functions, as mentioned, are handled too, and we can even handle variadic functions like printf. BridgeSupport metadata says whether it's null terminated or printf token based. BridgeSupport also gives us information about structs, like the types and names of the fields. I basically just wanted to show that in LuaCocoa, I go crazy with the meta methods and let you access properties in all different ways. That's the tables, array index, flat values, my name, and whatever. LuaCocoa now uses full user data, so meta methods are applied to all objects. There are a handful of special classes like NSArray and NSDictionary that get specialized treatment. Memory management is expected to work in a natural way for both sides of the bridge. A lot of time here is spent designing the system to make sure that it will work correctly in all cases. I feel that the thought process is worth discussing a little to potentially help those working on other bridges that want to get memory management right for their systems. But first, I want to mention Object-C garbage collection. Even though it's deprecated now, it had a huge impact on the design and implementation of LuaCocoa, so it's worth discussing. Object-C garbage collection is runtime activated. This places a burden on library writers to make sure their code works either way. LuaCocoa was the first to support dual mode. Most others did not even ever support it. So basically supporting dual mode comes down to this little dance. The trick is that the C functions, CF retain and CF release, remain meaningful in GC mode, but the Object-C retain, release, auto release are no ops. So you do this funny code dance such that whichever mode you're in, the retain counts work out the same way. So let's run through a few thought exercises. We create an object in Object-C and push it to Lua. If the object goes away in Object-C but is still active in Lua, it must stay alive. Solution: every time we create a new user data to push to Lua, we call CF retain. When the Lua GC finalize gets invoked, we call CF release. What if we push the same Object-C object into Lua twice? Do we reuse the same user data or create different user data? Solution: we reuse the same user data. This was a decision derived based on experimentation. There are nice benefits to having this one-to-one relationship, but to support the implementation so we can find and reuse the user data, we keep a map between the Object-C object pointer and the user data. We use a weak table in the Lua registry. The weak table prevents us from accidentally rooting the object and leaking. So if the object is already in Lua, we reuse that data, user data. If not, we create a new user data. When the object leaves Lua and gets garbage collected, the user data in the weak table goes away, so everything works out. We create an object in Lua and push it to Object-C. If the object goes away in Lua, but is still active in Object-C, it must stay alive. Solution: this one actually works out itself naturally. There is a nastiness if the object comes from a subclass created in Lua, but that's too much detail for this talk. I'll skip this. Being able to subclass in Lua is really useful, a really useful feature to have, because due to object-oriented nature of Cocoa, you often need to do it to get anything done. While Cocoa realized early on pitfalls of subclassing and started preferring a delegation pattern, you still need to create the class for the delegate object. I also wanted to take a moment to say that I am very grateful Lua is not an object-oriented language by default. PyObject-C and RubyCocoa have to deal with multiple inheritance headaches because there is a Python or Ruby object system and the Object-C object system, and the two worlds collide. This really drove home to me how well designed Lua is for embedding and coexisting. It just blends into the environment and works naturally. Defining a new class is done with a simple function. Just for reference, this is what a class definition looks like in Object-C. This is what it looks like in LuaCocoa. The most important thing to point out here is the method implementation for drawRoute. Notice it gets assigned to a Lua array instead of directly to a function. The first element is a string containing the Object-C type signature for all the parameters and return values. Objective-C needs type information, which we don't have in Lua. Now, if this was just an override, we can look at the signature through the Objective-C runtime, and this information is redundant. But if this is a new method to the class, there's no place to get the signature, so that's why I settled on this approach. Also, it's worth pointing out that all those OpenGL functions were provided through BridgeSupport. We didn't need to compile in OpenGL Lua binding wrappers. Everything just works. I'm going to skip the categories for time. They're very similar to subclassing. For time, I need to simplify this and just say that LuaCocoa supports multiple Lua states. But because there is only a single global Objective-C runtime, there's an impedance mismatch. Subclasses created in Lua states are visible across the entire runtime. And what if Lua states with the implementation get closed? Basically, LuaCocoa does some hoop jumping to try to make this all work, including fallback mechanisms. However, even then, this has implications and trade-offs. LuaCocoa needs to do extra cleanup for subclassed objects done in Lua, and we need to hook into the dialog and finalize to do it at the right time. Conventional object-oriented systems just rely on calls to super, but that doesn't work here because when we subclass in LuaCocoa, we're subclassing the real Objective-C object directly. There is no intermediate LuaCocoa object, and we don't have multiple inheritance. So instead, LuaCocoa uses swizzling to invoke the extra cleanup code and then chain the normal sequence of events. Also, finalize and dialog can be invoked from background threads. This can be big trouble with Lua. To solve, LuaCocoa looks for this and redirects to the origin thread as needed. This one is hard to explain and time is short, so instead of explaining it, I'm just going to say there's this hard case that happens when you subclass and subclass in Lua, i.e. subclass 2 levels deep or more in Lua. When you call super, you either get the wrong implementation or infinite recursion, and all the Lua bridges I've looked at never get this right. I saw that using FFI prep closure and also require you to name the parent class when you call super. I think the latter requirement could be lifted, but this is just getting this far was so difficult. I just celebrated and moved on. Blocks are the final and most significant addition to Objective-C. Unlike previous features that were mostly syntactic sugar, this one actually changes the semantics of how you use the language. Peter Norvig said that design patterns are a sign of a missing feature or deficiency in a language. I think blocks are a great example of this in action because blocks completely eliminated the need for the Cocoa delegate pattern. As a consequence, all the new APIs started using blocks instead. This means LuaCocoa must support blocks. I was hoping blocks could completely replace the need for FFI prep closure in LuaCocoa, but it turns out they fall a little short, so it must remain. Block support in LuaCocoa has all the stuff you would expect: proper memory management, ability to vote blocks in Lua, etc. You can also wrap Lua functions in blocks, and they can get used on the other side of the bridge as a block, which is pretty neat. LuaCocoa can autocurse Lua functions to blocks when needed as a parameter to a method, thanks to BridgeSupport. But if you want to create a standalone block, you need to explicitly provide the signature. And as I said before, the Objective-C side is important too. Public APIs are on LuaCocoa.h. This is the typical boilerplate you would see for getting started with LuaCocoa. It also contains APIs analogous to LuaC APIs, but for Objective-C types. This is an example of making a subclass in Lua, but then using it on the Objective-C side. This is the implementation. The most important thing here to note is I made a class called my Lua class. Now we're in Objective-C. The thing I want to point out here is, except for the animus class for string, this is pretty much canonical Objective-C. There's no Lua state here. The implementation details are hidden. This harks back to the philosophy that you can use LuaCocoa in the way that you want. Apple introduced App Sandbox to try to make the system even more secure. Mac App Store requires you to use it, but even outside the App Store, you can opt into it. It is generally a good idea to do so if you can. The good news is LuaCocoa seems to work with the App Sandbox. This is a really interesting edge case involving duck typing, but I don't have time to cover it. Feel free to ask me about it later. It was once feasible to port LuaCocoa to iOS, but nothing's changed and is now plausible. This is the recipe of what needs to be done. I'm just going to say for this, I think Ruby Motion is really interesting because it basically uses the power and removes the interpreter. So I think the Lua community could learn something by looking at it. But the reality is that Apple and the ecosystem is moving away from technologies like this, and the Swift language is now captivating the community's imagination. The pendulum has swung back to statically compiled native languages. People right now want to learn Swift, and they're demanding Swift purity, where even tiny amounts of Objective-C code or runtime magic are not acceptable. So LuaCocoa is sleeping. It's not dead because I had too many personal connections to it and let it go, but it is also not a high priority given the current environment. That said, I still welcome contributions, need stuff, please contact me. As slightly off topic, but as somebody who does a lot of cross-platform development, I'm hurting for a good cross-platform native GUI library. Yes, I use WWDC, which is cute, and I don't have time to go into a rant about this right now. I want something small, lightweight, native, and fast that I can use from different languages. IUP, a library created from the same university as Lua, comes very close to exactly what I need. I say almost because it does not have a native Mac Cocoa backend. But hey, I'm a Cocoa expert. I can fix this. So I started a port. This is a simple but real program that I'm using in production right now for Windows and Linux. This is me implementing enough that I can build and run this program right now. But it still has a lot to do before this is production ready. Like you can see, the layout isn't perfect yet. But this is possible, and I think it would be really useful for many people. Lua is a first-class citizen with IUP, but it has a C API, so it's designed to be used with any programming language, so a lot of communities can benefit. And I see a Mac port as a stepping stone to iOS and then Android. The problem is time and resources. I've been doing this on my alleged free time. So I'm reaching out to all of you to try to pull our resources to make this a reality. There are many ways to do this, so I'm asking each and every one of you to consider what resources you may have available to harness. So that's my first talk. Here's some links. And I guess I'll just maybe roll into the next talks as kinds of consideration, and then maybe we can take questions if there's time at the end of that for everything. I think I'm actually a little ahead.
There's a question here.
Yeah, I was going to say, you know Cosman's got his library, Objective-C, is part of this like Lua Power bundle thing. Did you know that? Or?
No.
Oh, okay. So I think that's like one of the main Objective-C bridges for Lua at the moment. I was wondering how you compared yourself to it.
Oh, which one?
It's called just Obj-C.
WWDC.
It's from LuaPower.com, Cosman's like website.
Yeah, no, very nice one. The big two, so one big two that I knew that came after LuaCocoa, the first one was Lua Wax. That was an iPhone-centric one.
Yeah, that's correct.
And then the next one is a LuaJIT, completely LuaJIT-based one, tiny LuaCocoa. That was actually really cool, but it's all LuaJIT, so it's very different than the way.
So yeah, the LuaPower one was also dependent on LuaJIT FFI, but now that the FFI is available for normal Lua, it works fine there as well, I think. I think that's what people have been using.
See if they do subclassing.
Sorry?
See if they do subclassing of a subclass.
Yeah, they do.
Did they?
Yeah.
Because yeah, that's the first time I've seen any, and that'd be the first time I've seen anyone else like try to get that right. But yeah, sorry, I'm not aware of those other two.
Okay.